Welcome back to another episode of Learning Integration. This is integration by parts, and we're going to be focusing on the exponential function of a to the power of x. So here we have function equals a to the power of x, and the integral is a to the power of x on ln of a being a number. And with this is Lagrange's way of doing the integration by parts. Just his notation is all. And you can pause it if you want to have a look, but other than that, I'm going to do our first example. Well, I'm only doing one example, but this example will have integration by parts done twice. Okay, so we have a function equals a to the power of x multiplied by sine x. I'm going to do this example with a to the power of x. I'm not going to use a number because it'll come out the same way anyway. It's not going to affect it dramatically. I'm just using a instead of a number. Okay, you can use a number if you want. I'm not. But anyway, first we'll start by finding the integral of both sides, capital F, and then the integrand a to the power of x sine x dx. Okay, so the question now, if you watched my previous bit by parts video, you will know that we compare this bit where I'm pointing roughly to this bit. So one of them has got, because we need to find f of x, g of x, f dash of x, and g of x, which we will find. Then we need it twice. But we don't have g of x here. We only have g dash of x. And we don't have f dash of x, we only have fx. So we need to find one of these to be these, and then work out what these will be from there. Now, that might sound a bit off, but okay, let's decide which one, because we'll have fx, and we'll need to find f dash of x. So we'll need to derive whatever we call fx, and we'll have gx. But we won't have we'll have g dash of x, but we won't have gx. So we need, whatever we pick as g dash of x, we need to find the integral of that to get gx, if that makes sense. So you pick one of these. Preferably, I like to pick fx to be the one that simplifies easier. And because I know that if I were to find the derivative of a to the power of x, I would get ln of a multiplied by a to the power of x. That's making it bigger, but deriving sine x, it just goes to cos x. It doesn't change in size, or it doesn't change in complexity, it just changes. So I'm going to call this fx, and I'm going to label this as g dash of x. I'm going to point out that people make the mistake of seeing this in this order, a to the x first and sine x, and then they see it in this order. So they think that they must call fx a to the x and sine x g dash of x, but that's not the case. If it's multiplied, if I wanted to, I could rewrite it and switch it around. It doesn't matter. If it's multiplied, it's multiplied. I could have sine on the front and ax on the back, but it would still be the same. Anyway, okay, so fx we'll call sine x, and g dash of x we'll call a to the power of x. Deriving sine x, we get cosine of x, and finding the integral of a to the x is just a to the x on ln of a. Would be plus c. If you're doing a standard question, you write plus c always, but because this is integration by parts, I don't do the plus c here, I do it later on. Okay, so I'll write this out now. So we have a to the power of x multiplied by sine x dx equals, what's fx? Fx is sine x. Gx is multiplied by a to the power of x on ln of a, minus the integral f dash of x cos x gx multiplied by a to the power of x over ln of a dx. Okay, now we have our formula. Now what am I going to do? I'm going to do a bit of rewriting and simplifying a bit. So, sin x multiplied by ax, a to the power of x, all over ln of a. Same thing, haven't really done anything except simplified and made it look neater. Subtract. This is a to the power of x multiplied by 1 over a. 1 over ln of a is a constant. Therefore, multiplication by constants rule means I can bring that out the front. And then we're left with just cos x ax dx. Now, this leaves us with a bit of a problem. What's the problem? Well, we have two functions multiplied together, so we can't just solve it. Easy. We have to use another integration by parts. So second integration by parts. Okay, so we start with cos x ax dx. I'm going to do it the same as I did it before. We're going to label this one as the fx, and we're going to label this one as the g dash x. Okay, so fx, f dash of x, we have fx cos x. That means the derivative of cos x is negative sine x. Now, gx and g dash of x. Our g dash of x will be our ax, and our integral of that will be ax over ln of a plus c, but I'm not going to do it here. I'm going to do it later when I've got the formula written out. Okay, so the other formula said we need here fx, which will be cos x, multiplied by gx, which will be a to the power of x on ln of a, minus the integral of f dash of x, which is negative sine x, multiplied by gx, which would just be a to the power of x on ln of a. And then there'd be a dx back here. Okay, now this is looking a bit complicated. So basically, we now have to sub everything from this point on into this bit. That's going to look a little bit messy. But if I can rewrite the beginning, what did we start with? We started with a to the power of x multiplied by sine x dx equals sine x a to the power of x on ln of a minus 1 over ln of a, and we're going to sub, what we're going to sub in here is this. So we're going to sub in cos x a to the power of x over ln of a, because I just simplified this, just multiplied the cos x on top. Now we have here, we can do multiplication by constant and bring this negative out. Therefore, a negative times a negative is a positive. Integral sine a to the power of x, oh, I forgot the x, over ln of a dx. Bracket. Okay, well, now this is looking a bit funky. A to the x, we're coming close to finishing though. Just got to do a lot of rewriting. Questions like this do come up a lot though, so let's do it here. Ln of a multiplied by ln of a. The top stays the same because it's just multiplied to 1. So cos x, a to the power of x, on ln of a squared. Negative, we're going to be multiplying a negative to a positive, so it's going to go back to negative 1 over ln of a integral. I'm just going to I'll write sine x a to the power of x dx. Now, I didn't write the ln of a because the ln of, I'm going to do something with it in a minute. ln of a, like I said before, is we're essentially multiplying the top by 1 over ln of a. 1 over ln of a is a number. Therefore, multiplication by constants means we can bring it out the front and multiply it. So, 1 over ln of a multiplied by 1 over ln of a is ln of a squared. All I did was just multiply this outwards to that. Okay, and I made it a squared. So now we're left with sine x to the power of ax. Then you're probably thinking, well shit, we've got now a function times a function. That means we have to integrate it a third time. No. This here, sine x ax, is the exact same as a to the power of x sine x. These two functions are the exact same, including the integral stuff. Okay, now we're getting somewhere. So what I'm going to do now is this stuff stays the same. All this stuff stays the same. I'm not going to rewrite it because I want to show you something here and it'll take forever if I rewrite it. But we have an ln to the power of 2 and an ln to the power of 2. All these have the same base except this, ln of a. So therefore, if we want ln squared, then we're going to have to multiply the top by ln of a as well. So it'll look like sine x, a to the power of x, ln of a, and that'll make the bottom ln squared of a. Now, think of it as we've got a squared, we've got squared, we've got squared. How do we get rid of all that? Well, we've got to multiply this side by ln squared of a, and this side, all of this, by ln squared of a. Okay? What this means is now, this will be ln, it'll be now ln squared of a, because I've got to multiply this side as well, integral a to the power of x sine x dx equals sine x a to the x ln of a minus cos x ax. And we don't have to write this bit, we just have to write, I can't fit it, but I'm going to have to write minus the integral of sine x ax dx. Because the ln squared, the 1 over ln squared a, I multiplied ln of squared a to it, which negated that, and got rid of that. Oh, got rid of that. Okay? So there's no more, there's nothing on the bottom anymore. It's just the problem is now on this side we've got an ln of squared a. But if you also look at it, we've got a minus integral of sine x multiplied by a to the power of x. That's the same as this part. If we bring it over this side, it'll make it a positive. So let's do that. Okay? Okay. So we have ln squared of a integral of a to the power of x sine x dx plus the integral of a to the x sine x dx. Now, I just rearranged these. That equals the exact same. I just brought it on the other side and added it. Okay? And on this side, we're left with a sine x a to the x multiplied by ln of a minus cos x a to the power of x. Okay, I hope that wasn't too messy, but I hope you understand that this side is just this line here, the top part. This bit I added to the other side. It's getting a little bit messy now, but these things do sometimes come up, and it's good to know how to do problems like this. Now, we have an ln of a multiplied by this, and we could think of having this being multiplied by 1. Therefore, we can actually factor out this integral of a to the power of x sine x dx. We can factor it out. And what that will look like is this. Because think of it, if we multiplied this into that and then this into that, we would get this. This is just simplified. We just factored out the integral. And on this side, we're still left with sine x multiplied by a to the x multiplied by ln of a minus cos of x multiplied by a to the x. Now, how do we get this on its own? Simple. We just grab this and divide it. Therefore, the integral of a to the x sine x dx, which is just the integral of a to the x sine x, equals sine x a to the x ln of a subtract cos x a to the x all over ln squared of a plus 1. Now you could go a step further, don't hate me, but this is maths, it should be fun. So we're going to factor out the ax because we have an ax on either side of the subtraction. Sine x ln of a minus cos of x all over ln squared of a plus 1. And there you go. The integral of a to the power of x sine x is this. Thanks for watching. I hope you learnt something, and have a good day.